All right, so our lesson today focuses on something that we call the line of fit. The line of fit. So if something fits, right, it's basically, what am I trying to say? A line of fit is going to fit within most of the points on the scatter plot. So you're going to see the line kind of pass through, or at least around, most of the points on the scatter plot. You're not going to see just a random line like off to the side that... All right, what's the line of fit? So the line is going to be drawn on the scatter plot in the vicinity of most of the points, but the catch is it doesn't have to necessarily pass through any of the points. So you're going to see it's in the general area, but the rule for line of fit is that it doesn't necessarily have to pass through the points. All right, you guys got that? Okay, so there's a lot going on in this slide. This is the only one that we're going to do here, and then we're going to switch over to big ideas and work a couple problems in big ideas. All right, everybody have your pencils? Okay, ready to go? So here we have a scenario. The table shows you the number of absences in a school year and the final exam scores for several students. So it gives me 10 students, how many absences they had, and what their final exam score was. So we're going to make a scatter plot of the data and draw a line of fit on the graph. Okay, then we're going to write an equation, and we're going to interpret the slope and y-intercept. So there's a lot going on here. Let's start off by setting up our scatter plot. So what is my X category? According to the table, which category is X? Absences. Okay, so go ahead and label your X category, absences. All right, and you can see, I'm just going to go ahead and show you how I set up the intervals. All right, and I want you to do that the same way. So please skip every other block, okay? So every other block. So skip the first block and then write a 2. Skip the second block, write a 4. Skip the third block, write a 6. All right, go ahead and set up your scatter plots. Okay, all right, so let's start plotting our points. Our first point, my first student has how many absences? 0 absences and scored a 97. All right, so I'm going to go 0 up 97 and plot my point. So again, you're just kind of hitting right in between the 95 and the 100. It's not going to be exactly to the number because we have such a wide range of numbers, but it's close enough. All right, now let's do the next one. Over 3 up 88. The next student had 3 absences and scored an 88. All right, these are just facts, okay? Well, facts according to the story. So, student number 2. All right, there's the statistic. Student number 3 had 2 absences and scored a 93. All right, so these are real scores. Student number 4, had, is that the 4th or 5th? Yeah, 4th student. 5 absences and scored an 83. So I'm just going across and plotting the points where they go on the scatter plot. All right, next one. 7 absences and scored a 73. All right, so go ahead and do the last 5 points on your scatter plot. I'll give you guys a minute to do that. All right, so here's the rest of my points. Okay, does yours look similar to that? All right, over on the, looks like the 8 absences, do you have 2 points on the 8? Okay, 2 points on the 5. So does your scatter plot look similar to that? It should look very, very similar. All right, so now what you're going to do, and on your quiz and your test, I will give you the ordered pairs to use, okay? So everybody will be on the same page because there's no constant rate. Depending on which order pairs you choose, your slope can be different. All right, so I'm going to ask you to write an equation for the line of fit. All right, so of the line that passes through these 2 points. Now, I got these 2 points from the table. Okay, those are the 2 points that I'm asking you to use. So that way we can all get the same slope. All right, so in order to write an equation, what 2 pieces of information do you need? Everybody, the slope and the what? The y-intercept. Can I find a slope from ordered pairs? All right, so you guys all did that last week on your test also, right? Okay, I need you to find the slope using these 2 ordered pairs. Go ahead and do that. So did you do 88 minus 97? Did you do 3 minus 0? Negative 9 over 3 reduces to what? Negative 3 over 1. Now, so that's my slope. Now, does anything in my ordered pairs tell me what my y-intercept will be?
0.
Yes, the ordered pair that's matched with a 0 for my x value. Okay, so what is my y-intercept? 97. Remember what the y-axis stands for. All right, so let's look at this equation. Y equals negative 3x plus 97. All right, do you see how I put that together? So now, here's the challenging part. I need to interpret the slope. What does it mean to have a negative 3 over 1? Well, slope is rise over run. Does everybody agree that slope is rise over run? If I were to plot this on a graph. All right, so what does my rise value stand for? What is my y? The scores. So a negative 3 would mean that the score would go down by 3 points. All right, so I just want you to write PTS next to it. So that means negative 3 points. So you need to understand that that value on the top is telling me the change in my y value. So I'm predicting that the score will decrease by 3 points per every, okay, so run would be my X category. And what is my X category? Absence. Per 1 absence. So I put ABS for absence. Now I'm going to put that into a sentence. I can expect or predict the score to decrease, or I said drop, same thing, 3 points per absence. All right, do you see how I got that? The 3 was negative, so the score is dropping. How did I know it was score? Because it's rise over run, which means y over x, my change in y. My category for y was the scores. All right? Yes, Lila.
It doesn't matter which
I'm going to tell you which ordered pairs to pick because technically there's not a constant rate of change. Basically, I can't predict, right? If you have 2 absences, this is going to be your final exam score. I can't predict that, right? So because there's no constant rate of change, meaning if this happens to X, if you get 3 absences, you're going to get the score. If you pick a different set of ordered pairs in here, you're going to get a different slope, okay? So what I'm saying is the line of fit. So the line that we're about to graph, all that is a trend. All that is a pattern. It doesn't say like this is set in stone, I guess. It's basically an estimation. All right, so that's my slope interpretation. Which ordered pair told me the y-intercept? The one with the 0, right? So when a student has how many absences? 0 absences, we could expect what kind of score? Okay, so a student with no absences can expect a score of 97. Now, again, don't you wish it worked like that? Hey, guys, if you have perfect attendance, you can get an A on your final. Okay, but is that how it works?
No.
All right, you don't get an A for effort. All right, so there is no definitive correlation here. However, Doesn't it make sense that the more school you miss, you're probably not going to do as great on your final, right? If the more absences you have and the more school you miss, the harder it is to catch up. And we've seen that now more than ever, right? With all the COVID absences and everything. Okay, so there's my interpretation. The last thing I need to do is plot my line of fit. I need to graph this equation. All right, now remember what we said about line of fit. It's not going to pass through all the points. And that's okay. Where would my first point go on this equation? Let's just graph it like we always have. 97. So I want you to come up here, and it just so happens to be a point on the graph, which is fine. All right, so I changed the color to an orangish color. All right, so you could just circle that point if you want. And now you're going to follow your slope for your next point. So your slope says that you should go down 3 and over how many? Down 3 over 1, plot your point, and you draw your line all the way through the points on the scatter plot. So as you can see, the line passes through some of the points, but not all of the points. All it is showing you a trend. All right, the line of fit. Basically, this is where the points should kind of cluster around. All right, any questions? Okay, so that's it for the PowerPoint. I know there's a little bit more in the notes, but I would rather switch over to big ideas. And I'm going to do some of it with you, and then I'm going to leave you guys to do the rest of it, and it'll count as your homework grade. All right, so I just need cell phone pouch numbers 1 through 10 to go grab your Chromebooks, please. And I'm actually going to include the rest of this on the recording, so we're going to keep recording so the people who are absent can see us work the homework too. All right, so I'm going to review over numbers 1 through 5 with you, okay? I'm not going to do them with you, though. These are the ones you're doing on your own. Are you paying attention? Stop talking. You should have a blank sheet of paper out. Okay? All right, number 1, describe the relationship. Then you will identify gaps, outliers, gaps, and clusters. So your outliers, whatever goes, your outliers, gaps, or clusters. Okay? All right, number 2, same thing. Describe the relationship, identify outliers, gaps, and clusters. Number 3, write the fraction as a decimal and a percent. Because it is 29 out of 100, you should be able to do that mental math. You're not required to show work. All right, 29 over 100 as a decimal and a percent. Number 4. All right, choose a scatter plot with the line that you think best describes the relationship. So look at the points plotted on the scatter plot compared to the table. Which one of them represents the data? All right, so that's number 4. All right, and number 5. Now we're going to stop and we're going to spend some time on number 6. All right, so you can consider this an extension of your lesson today. All right, we're going to work through this problem together. The first thing I need you to look at is which one of these scatter plots correctly represents the data. Okay, which one of these scatter plots correctly represents the data? I want you to go ahead and choose. Okay, which one? The first one or the second one? Go ahead and highlight the correct one. Okay, so which one do you think? It's the second one. It's the second one. Now, how did you know that? All right, look at 30 and 45. This one has a point plotted at 30 and 45. Same thing with 36 and 43. I see a point pretty close to 36 and 43. All right, so that's how I knew that this was the correct scatter plot. All right, so based on that answer, now I'm going to come down and I'm going to answer the rest of the questions. So it says a line that best approximates these points could pass through which 2 points below. So it gives me these 3 options as potential answers that you could click and drop into that box. I want you to decide which set of points would be most likely or best approximate, all right, a pass-through point for the line of fit. So go ahead and choose your answer. Try to at least get your best attempt answered before I show you the correct answer. All right, so everybody see if you can pick the correct ordered pair. Duo. Vivian, what did you say?
30 and 45 and 60 and 30.
Yes, ma'am. She is exactly correct. 30 and 45 and 60 and 30. How did she know that? Because these are actually points that are plotted on that scatter plot. For the other two choices, those points weren't plotted on the scatter plot. So the likelihood that the line of fit passes through those points is pretty slim. All right, do you see why we chose these 2 points? 30 and 45 and 60 and 30, both are points on that scatter plot. All right, so now I'm going to write an equation. So here's the kicker. It says write an equation of the line of fit, what? Using the points that you chose above. So by telling us that, we're all going to get the same slope because we're all going to pick the same 2 points versus coming back up here to this table up at the top and it's just a free-for-all on the table. Oh, we'll just pick whatever 2 ordered pairs. No, it tells me specifically write an equation of the line of fit using those 2 sets of ordered pairs. So I want you to do that, all right? Now, what 2 pieces of information do you need for writing an equation? You need the slope and you need the y-intercept. Can you find slope with 2 ordered pairs? Absolutely, okay? So we're going to say m equals, everybody say your formula with me. y2 minus y1 over x2 minus x1. So out of these 2 ordered pairs up here that I chose, which number is my y2 value? 30. And then which one's y1? 30 minus 45. You finish the rest. Find your slope. Okay, so finish finding your slope using those 2 ordered pairs. Okay, so what did we subtract on top? 30 minus 45. Guys, up here are my ordered pairs. This was my x1, y1, x2, and y2. That's how I knew to subtract 30 minus 45. Over which one was my x2 value? 60 minus what? 30. Okay, so I get negative 15 over 30. What does that reduce to? Negative 1 over 2. Okay, so now I have one piece to the puzzle. I have my slope. Now I need my y-intercept. The problem is, okay, in the last example that we worked on the PowerPoint, the table, the ordered pairs told me my y-intercept. Do my ordered pairs tell me my y-intercept? Look up here. Look up at the table. Does any ordered pair have an x value of 0? You got to do the what? Oh, it starts with a P. Point slope. Point slope. Let's review the formula. So if no ordered pair tells me the y-intercept, I must do point slope. Let's say the formula together. Y minus y1 equals m times x minus x1. You have one question on your quiz next Monday, week from today, that looks like this, okay? Where you have to plug it in. Now, does it matter which order pair you choose?
Yes.
Nope, doesn't matter. You can choose either one of the ordered pairs. We're going to do the second one, just because I feel like it, okay? All right, so let's plug in the numbers. Y minus, okay, so in my second ordered pair, which one is my Y value?
30.
Pay attention, okay? So Y minus 30 equals negative 1/2 times x minus 60.
I need to do that now.
All right, so now I'm going to distribute negative 1/2. What's half of 60, guys? All right, spit your gum out, please. All right, what's half of 60? 30. All right, so 2 negatives, that's going to be positive, right? So I have y minus 30 equals negative 1/2 x plus 30. One more step to get it in slope intercept. What's it going to be?
Plus 30.
Okay, plus 30 on both sides. Now, it's a lot of steps, guys. You're not ready for the test, let alone the quiz. We still have a lot more practice that we need to do. Okay, but the only way for us to get to the point where you can do these on your own is just to practice them. All right, so y equals negative 1/2 x plus 60. This is the equation that goes in this box on number 6 for your big idea. Okay, all right, so we're going to interpret it now. What is the slope? We just wrote the equation. Now, are there any fraction options here? Are there any options that are fractions? No, but do I know the decimal version of negative 1/2? Okay, 0.5. So negative 0.5 should be dragged and dropped here. See if you can fill in the next box. According to the equation, which value of those boxes down in your options is the y-intercept? Drag it in or click it and drop it. I think if you click the box and then drop it into the empty box. Go ahead and answer. Zoe, what number did you drop up there? It is 60. 60 is the last number in my equation, so it's the y-intercept. How are we doing so far? Okay, so you could predict that 60 hot chocolates are sold. So here's your y-intercept interpretation. If it's intercepting y, that means my x value is what? 0. Okay? So if I sold 60 hot chocolates, that would mean that my temperature is 0. 0. For my y-intercept, my x value has to be 0. So this is 0 degrees Fahrenheit. Okay? Now look at your slope. Is everybody looking at the slope? What was my slope? Negative 1 over 2. Does everybody see my slope right here? Negative 1 over 2. Remember, this is rise over run. So negative 1 is my y, my change in my y. What does y stand for? Look up at the graph. What did y stand for? Hot chocolates, didn't it? Look up at the graph. Y is hot chocolates, right? So because it's negative 1, does everybody see that the top number is negative 1? That's my change in y. That's why it says that the sales decrease by 1. That's what the negative 1 means. Okay, so now you need to fill in the second box. What does this denominator number mean? All right, so go ahead and try to fill that in. The slope is telling me that the sales will decrease by about 1 hot chocolate for every what? Every 2. The 2 on the bottom, guys, says, and because it's positive, it's an increase in 2 degrees Fahrenheit. Doesn't that make sense? Right? Doesn't that make sense? The warmer it is, the less hot chocolate you're going to sell. Anybody want hot chocolate or crave hot chocolate when it's 90 degrees outside? No, we want hot chocolate when it's cold. Right? So as the temperature increases, what happens to the sale of the hot chocolates? It decreases. All right, so I'm going to go off this screen and I'm going to scroll back up. That's why you see a negative relationship here. As the temperature increases, the sale in hot chocolates decreases. And yes, that does make sense. All right, this is not an easy concept. It's not easy when you have to start interpreting equations. All right, but I think the more we practice it, the better you guys will get at it. Okay, look at number 7. We didn't have time to talk about correlation coefficient. We might at a future time, but you don't have to answer the R part. You do have to find an equation for the line of best fit. All right, it says this number of visitors at an amusement park each year for the last 8 years. Find an equation of the line of best fit around the slope and the y-intercept. Okay, so you don't have to do a correlation coefficient. And same thing with number 8. I just want you to write an equation. Okay, so do 8a, but you don't have to do the R part. All right, so you don't have to do the correlation coefficient or the interpretation, but you must, and I will be reading them. I got a lot of time over the next day or two because we're doing the MAPS test. You must answer B and C. And I am checking your work. I cannot make this more clear. If you don't have your homework work tomorrow in class, I cannot give you credit for your homework. Okay? The only 3 problems is 6, 7, and 8 that you have to show on your paper. 1 through 5, you can do it in big ideas. You don't have to show work. All right? Does everybody understand? Okay? So, like I said, need a little bit more practice, but hopefully that was helpful, at least for a start. All right? That's everything you need to know.